Principles of Bioproduct Separation, Module 11, Ultrafiltration and Electrophoresis, Segment 2, Ultrafiltration. With me, Yusuf from School of Life Sciences and Technology, Institut Teknologi Bandung. We have previously discussed about basic ideas. In this segment, we will discuss about ultrafiltration. Ultrafiltration is a membrane process which depends on the ability of a permeable membrane to differentiate between solids of different sizes. Ultrafiltration processes have three distinctive characteristics. They use a high cross flow, they are dominated by the membrane, and they depend on the membrane geometry in the actual equipment. Ultrafiltration almost always involves a large flow across the membrane surface, perpendicular to the flux through the membrane. When solid particles are being ultrafiltered, the cross flow minimizes the development of a filter cake which will retard the process. When a macromolecular solution is being ultrafiltered, the cross flow reduces concentration polarization that augments the osmotic pressure and hence reduces the flow through the membrane. Ultrafiltration is critically dependent on the membrane, which can be generally categorized into three types. The first type is made of cellulose ester or other polymers by spreading a thin layer of organic solution on water, glass, or an inert support. The membrane has a porosity of about 80% and average pore size ranging between 0.1 and 1 micrometer. This type of membrane is stable over wide ranges of pH, temperature, and organic solvents. The second type of membrane is made by drawing warm, non-porous film of polymers like polypropylene. This membrane has a porosity around 35% and a thickness of 0.003 centimeters. Because they are hydrophobic, they must be primed with alcohol-water mixtures before ultrafiltration of aqueous solutions. The third membrane type is made by exposing non-porous films of mica or polycarbonate to a radiation. The radiation tracks in the film are then etched away with hydrofluoric acid. This membrane has the lowest porosity, around 3%, but by far the most monodispersed pores. The third key characteristic of ultrafiltration is the membrane geometry in the actual equipment. There are four common membrane geometries. The first type is flat sheet. It has a membrane area up to 1500 m². It can be disassembled for cleaning and for replacement of defective membranes. It has the smallest area per volume of the common types, so tends to give low ultrafiltration fluxes per volume. The second type is shell and tube. It is harder to clean and has lower area per volume and hence lower fluxes than the spiral wound and hollow fiber geometries. The third type is spiral wound device with up to 2000 m² of membrane area. They are much harder to clean and often must be discarded even if part of the membrane fails. The fourth type is hollow fibers. It has a huge area per volume, up to 3000 m² per meter cubic, which allow the highest fluxes per volume. However, they plug easily and hard to clean. For a dilute solution, osmotic pressure can be calculated using equation 14. Concentration polarization near membrane surface is shown in the right figure. Due to incomplete mixing in a tank, concentration at the membrane surface may be much more than that in the bulk because the solvent flux through the wall stands solid near the wall. Concentration polarization augments the osmotic pressure and hence reduces the flux through the membrane. The flux can be estimated using equation 15 until equation 18. A plot of flux versus the logarithm of reservoir concentration C1 should be a straight line. In order to estimate the ultrafiltration time for a given volume, let's consider the case of a little concentration polarization as shown in equation 19. Mass balance on the solvent can be described by equation 20. Because all the membrane rejects solids, all the solute, the total solid is constant and can be expressed by equation 21. Equation 21 can be easily integrated to yield equation 22. For the next segment, we will discuss about electrophoresis. Until then, I am Yusuf from Institut Teknologi Bandung.